Hello, my name is Britta Peel, and in this lecture I'm going to discuss the feedback loops in the female reproduction system. In order to do this, I think the best way is to walk through the female menstrual cycle. That'll allow us to discuss the hormonal control of each stage and the feedback loops that occur. And we're going to be doing this for a woman who is not pregnant. Okay, so just some general information that I want to cover. The menstrual cycle can be described either as the ovarian cycle, which is focused on follicle development, or the uterine cycle, which focuses on the endometrium of the uterus. Generally, the cycle lasts approximately a month, between 24 and 35 days, and both ways of looking at the menstrual cycle have 3 phases, and we'll discuss those in detail in the upcoming slides. Hormonal control of female reproduction follows a basic pathway that is also seen in the male reproduction system, and that it starts in higher brain processing centers, the CNS, which acts on the hypothalamus, which then acts on the anterior pituitary, and in turn acts on the gonads. So for males, that's the testes, and for females, it's the ovaries. So we're going to be looking at the ovaries. The feedback pathways that are in the cycle are complex, but generally trophic hormones, so those are hormones that act on other hormone-producing tissues. They exert negative feedback. And gonadal hormones, so those are hormones that are produced by the ovaries. They exert a long loop feedback system, so they loop back and act on the hypothalamus or the anterior pituitary itself. So yeah, we'll move forward. Okay, so the ovarian cycle focuses, as I previously said, on follicle development. So the first phase is the follicular phase, which is a period of follicle growth in the ovary, and it's the longest lasting phase, and it lasts anywhere between 10 and 21 days. The next phase of the ovarian cycle is ovulation, where one or more follicles have ripened, and the ovary releases the oocyte from the follicle itself, that's the egg. And we can see that happening here after a period of 2 weeks. And then the third and last phase is the luteal phase, in which the ruptured follicle develops into the corpus luteum, and the corpus luteum then starts secreting hormones for pregnancy preparation. And if pregnancy does not occur, the corpus luteum ceases function after about 2 weeks. So the reason I'm discussing these phases is we'll later discuss the hormonal control that happens at each of them. So it's important to be clear of what's happening in the ovary at each of the phases to know how the hormone is stimulating that change. Next, we will quickly just discuss the uterine cycle focused of the menstrual cycle. And so as previously stated, this focuses on the endometrial lining of the uterus and the changes that occur there. So the first phase of the uterine cycle is menses, which is menstrual bleeding from the uterus. It corresponds to the beginning of the ovarian follicular phase, so they're in parallel there. The next phase of the uterine cycle is the proliferative phase, in which the endometrium adds new layers of cells in preparation of pregnancy, and this corresponds to the latter part of the follicular phase of the ovarian cycle. And then the third and final phase is the secretory phase, which is post-ovulation, in which the corpus luteum hormones convert the endometrium into a secretory structure, and this corresponds to the luteal phase of the ovarian cycle. And if no pregnancy occurs, so that's going to be in our case because we're looking at a non-pregnant woman, the superficial layers of the endometrium are lost in menstruation, and the cycle begins again. So here in this figure, we can see menses occurring at the beginning, in which the superficial endometrium is sloughing off. And then the proliferative phase, it's growing in depth here. You can see there the endometrium is adding new cell layers, and then the secretory phase is when it's converted into a secretory structure to prepare again for menses. So it would loop back here if this figure kept going. Okay, so the hormonal control of the menstrual cycle, female reproduction, primarily relies on a couple different hormones. The first being gonadotropin releasing hormone from the hypothalamus, which is stimulatory of the anterior pituitary. So when it's released from the hypothalamus, it acts on the anterior pituitary. The anterior pituitary has two hormones, follicle stimulating hormone and luteinizing hormone, and those hormones are released and act on the ovary itself. And then the ovary releases a couple of hormones, that being estrogen, progesterone, inhibin, and anti-Müllerian hormone. So this figure was on an earlier slide, but I've expanded it to add a little more information so we can talk through it. So the feedback that is occurring via these hormones is summarized here in this table. So low estrogen, and I'll just quickly note, androgens are male hormones, so testosterone. So we'll just ignore those. This figure is for both males and females. So low estrogen levels, so that's the ovaries are not producing estrogen. There's an absence of negative feedback, so gonadotropin releasing hormone increases, and that would then increase the luteinizing hormone and follicle stimulating hormone that are being released from the anterior pituitary, which will then act on the ovaries to increase estrogen production. When moderate levels of estrogen is being produced, it acts in a negative feedback loop on the hypothalamus to decrease gonadotropin releasing hormone, and also in a negative feedback loop to act on the anterior pituitary to decrease luteinizing and follicle stimulating hormone. The way that I like to think about this is these hormones act to increase estrogen production. So when there's already estrogen being produced, it loops back to say, I'm already here, you can stop stimulating more production. And then lastly, estrogen is unique in that when there's sustained high levels of estrogen for longer than 36 hours, and we'll see this a little bit later, it actually switches from negative feedback to positive. So that being, it starts acting on the hypothalamus and the anterior pituitary to further increase the production of luteinizing hormone, gonadotropin releasing hormone, and follicle stimulating hormone to increase estrogen production even further. So we'll move forward to discuss the hormonal control at each stage of the menstrual cycle more specifically. Okay, so now we're going to talk about each phase and the control that's happening. This figure is really complicated. I'm going to do my best to explain it briefly. So just before the beginning of the early follicular phase, follicle stimulating hormones level increase, causing a tertiary follicle to start maturing into what will become the egg that is released during ovulation. So that you can see that here, that follicle stimulating hormone is increasing at the beginning. And so follicle stimulating hormone will then act on the ovaries to produce estrogen and progesterone. So those levels start to increase. We can see that as well. And those steroid hormones are produced in the granulosa cells, which is depicted down here. So they're producing estrogen. And they're also producing anti-Müllerian hormone, which acts to prevent further follicle development from other follicles. So we're only having one follicle, maybe 2 or 3 develop per menstrual cycle. So gradually estrogen increases, and it's exerting negative feedback then on the follicle stimulating hormone and luteinizing hormone of the anterior pituitary, as well as negative feedback on the gonadotropin releasing hormone in the hypothalamus. But it switches at the end to mid-late follicular phase, and it's going to switch to positive feedback, and that's seen down here. So estrogen is at our highest level right here, and it's going to switch to a positive feedback in which gonadotropin releasing hormone from the hypothalamus is increased, which will then increase follicle stimulating hormone and luteinizing hormone. Mainly luteinizing hormone is increased because inhibin, which is also produced from the granulacing cells, is acting negatively to diminish the production of follicle stimulating hormone. So this surge in luteinizing hormone is what actually contributes to ovulation, so the release of the oocyte from the follicle. And so the ovulation occurs, and then in early to late luteal phase, the corpus lutein starts producing progesterone, estrogen, and inhibin, which then again exert negative feedback on follicle stimulating hormone and gonadotropin releasing hormone. Progesterone influences the endometrium to develop into that secretory structure that we were talking about earlier in preparation for pregnancy. And what's interesting to note is progesterone has a thermogenic ability as well. So it actually increases the body temperature in the woman by approximately 0.5 degrees Fahrenheit until menstruation occurs. And then next we have the late luteal phase and menstruation itself, in which spontaneous apoptosis of the corpus lutein occurs following its 12-day lifespan. So as the luteal cells begin to degenerate, progesterone and estrogen productions drop. And with the drop in progesterone and estrogen, the negative feedback that was seen on follicle stimulating hormone and gonadotropin hormone is released, so their production starts to increase, and we can see that here. These are going back up. This is at the tail end in menstruation. Here you can see follicle stimulating hormone, luteinizing hormone are starting to increase as the progesterone and estrogen drop off at the end. And so then the cycle will resume back up again as follicle stimulating hormone increases. One more quick note I wanted to add, I realized I forgot a little loop down here, and that is in when the ovary starts producing higher estrogen at the beginning of the follicular phase as a result of increases in follicle stimulating hormone, the estrogen that is produced not only exerts negative feedback on gonadotropin releasing hormone and follicle stimulating hormone and luteinizing hormone, it importantly induces positive feedback on the granulosa cells itself to further increase the estrogen production, despite the decrease in the follicle stimulating hormone and luteinizing hormone. So yeah, just wanted to make that note. Okay, so now quickly, I'm running out of time. With this last slide, we're going to put everything together. So follicle stimulating hormone seen down here, that begins our cycle. So that's stimulating follicle development. Generally, estrogen dominates the follicular phase. We can see that here, this peak of estrogen, that's what's continuously increasing. And then right before ovulation, it's at its highest point. That highest point of estrogen contributes to the surge in luteinizing hormone as its negative feedback switches to positive feedback on the anterior pituitary and the hypothalamus. Luteinizing hormone and follicle stimulating hormone dominate the ovulation phase, and then progesterone, which is produced from the corpus lutein, dominates the luteal phase, and we can see that down here. This is a summary of what's happening to the endometrium. We can see the temperature that I was talking about down here. It increases as a result of progesterone production during the luteal phase. And I only have about 40 seconds left before it's going to cut me off. So this assignment was good. It helped me understand anything, and thank you for watching this video.